Well, hello pre-calculus students and seeker of general truths. In this video, we will explore this special case of 0 factorial, right? Because if we think about factorial, so if we think about something like 7 factorial, then that's really equal to 7 times 6 times 5 all the way down to 1, right? So that's 7 times 6 times 5 times 4 times 3 times 2 times 1. But what about, and all the factorials stop at 1, but what does it mean for us to say 0 factorial, right? Well, we can reason through this even if the factorial for 0 doesn't fit into our normal definition. Okay? And the way we're going to reason through this is as follows. We're going to start out by saying that n choose n is equal to 1, always, for any value of n greater than or equal to 1. Okay? So, for example, if I have 7 people and I want to choose a group of 7, right, then there is exactly one way for me to do that because I got 7 people and I have to pick all of them. Okay? Well, along those same lines, we can say that n choose 0 is also equal to 1. Because if I have 7 people and I don't pick anybody, I want a group of 0 people, then there's only one way for me to do that, right? One way for me to make that selection. And you can kind of see the same example up here, right? That if I choose 7 people, it's like I'm choosing 0 people. I'm eliminating 0 people. Or if I choose 0 people, then that's like I'm saying I'm eliminating all 7 people. So this means the same thing. Okay? So we're going to start with this right here as a basis. N choose 0 is equal to 1. And let's expand. Let me draw a line here. And let's expand that. What does n choose 0 actually means? Well, the definition of combination is n factorial divided by r factorial, in this case 0 factorial, okay, times n minus r factorial. Okay. So if I expand it, this is what I get. Well, let me continue on over here. Now let's simplify. The numerator is still n factorial. The denominator is 0 factorial. And n minus 0 is just n factorial. And we know that this is equal to 1. Okay. So now the n factorials in the numerator and the denominator cancel each other out. So we have 1 over 0 factorial is equal to 1. Take the reciprocal of both sides. And the reciprocal of the left side is 0 factorial. And the reciprocal of the right side is just 1. Okay. So here we have it, a proof using our intuition that 0 factorial is in fact equal to 1. And just a quick side note, there are such things as negative factorials, but we are not going to get into that here. That gets a lot more theoretical, and we want to stay more in the realm of what is tangible, at least for this part of the course. All right, so this is a helpful identity to think about. I mean, to have, because it will come up in when we go on and prove bigger proofs and explanations. Okay, as always, thank you for watching and have a wonderful day.